Okay, in this video we have an interesting test, very particular. It's called the GoodnessofFit Test. Basically, if you have a variable that you think has a certain distribution, so you think the outcomes should be distributed a certain way, you can actually test whether or not they are. So we're going to have some fun in this particular video. I have some cool stuff in mind, so we'll see if it works. So the idea here is, and I always use this example to illustrate it, M&M candies. They've stopped printed what their expected distribution is, but they used to have this file. I found it in 2008, I think. They gave these distributions for what the colors should be in a particular package. So the question is, we're going to look at it and say, well, are they? Are they really distributed? Do we have enough information to say that the distribution is different from that? So we're going to try this here. We're going to go, and I have some actual packages of M&Ms. I have two here because, you know, larger sample size, plus I like M&Ms, you know, so you can't go wrong. Can't go wrong with M&Ms. And what we're going to do is we're going to count the frequencies that we have and see what we would expect and see if they're different. So let me do that here. I'm going to open these up. Oh, easy open here, right? Holy cat. All right, there's one. Oh, I can smell them. Can you smell them? Huh. They smell good. I'm going to eat some of these. These are not going to make, they're not all going to make it to the end of the video. Whoa, there's a lot of green in that one. Okay. Holy cow, that's a lot. All right, so now what I need to do is I think I need to zoom out is what I need to do. We're going to need to count these, figure out how many we have of each color. So what should I start with? So let's see here. Let me grab my calculator. Just get this up here. And let's figure out how many total M&Ms we have. So we have, oh, you can't. So 110 total. So we have a total of 110. Now, I covered up these percentages here. This is what we would expect. So if we zoom in, those are the percentages we would expect. So if we have 110, we'd expect 24% of that 110. So 24% times 110, we'd expect, and I'm just going to do tenths place here, 26.4. Orange, we'd expect 20%. So what would that be? 22, right? I don't trust my calculations on the screen. So what we're going to do now is we're going to look and get a comparison between the observed and expected. But before we do that, we need some more machinery. We need some distribution. So let's go back to the PowerPoint and introduce a new test statistic here. So what we have is a chi-squared test statistic. And what it does is it compares the observed values with what you would expect. And it's this sum here. We're going to use StatCrunch to calculate this, but it takes all the observed values minus the expected values, squares them, and divides by the expected values. And it follows that chi-squared distribution that we've used before. There are some criteria. All the expected frequencies have to be greater than 1, and no more than 20% of the expected frequencies have to be less than 5. So what they can do, if some of these fail, if you have a category that has less than 5, and if you look here, ours are all good. None of our expected values are less than 5. But if they were, you could just combine a couple of categories. So what that does is that gives us a goodness of fit test. The null hypothesis is always that we follow the distribution, and the alternative is that we don't. And it's always right-tailed because the further values are from the expected values, so if we go back to that statistic, the further the observed ones are from the expected values, the larger this will be. And so that's what you're testing. Are they far from it? So it's always a right-tailed. You're always looking for if chi-squared is bigger than your particular value. And then the steps you know against test statistic, p-value, etc., etc. So I have some blanks here because we need to use StatCrunch. So let me open up my, where is my StatCrunch window? There it is. And so I have some blanks here we're going to fill in. So we had blue was observed was 22, 26, 23, 19, 12, 8. And then expected, whoa, expected 26.4, 22, 17.6, 15.4, 14, whoop, 14.3, 14.3. And then to do the test, it has its own drop-down menu under Stat Goodness of Fit. And then we're going to do that chi-squared test. And so the observed are in the observed column. Expected, if you like a rolling a die and you're counting up the number of 1s, 2s, 3s, 4s, 5s, and 6s, you'd expect them all to be equal. So you can do that. Ours are not. They're not all going to be equal. So we're going to put ours in the expected. We had to manually calculate that. And there's no quick way to do that. We had to manually calculate how many to expect. There's no quick way to do that. Sorry to break the news to you. A lot of times StatCrunch does that for you. This time you're going to have to calculate those. We can display the expected. That's fine. It's not a big deal. So we'll compute. And so here we have, ooh, can I keep all this? I'm going to move this to my other monitor here. Oh, where do I want to go? Oh, I can't move it. Dang it. All right. So let me see if I can remember all that. So we have chi-square is 7.10 and we have 0.213 p-value. So we have 7.10 and the p-value was 0.213. So not that different, right? I mean, it's kind of a small p-value, but it's certainly not less than our alpha. So we do not reject the null hypothesis. And so, no, there's no evidence to say that the distribution is different. Or shouldn't say there's no evidence. There's not enough evidence, here am I clicking here from typing, to claim that the distribution of colors is different from 2008. Oh, it's kind of weird that it wraps around like that. I can't even do an enter, so that's kind of weird. Anyway, now of course they might be different, right? We're not saying that they're definitely exactly the same as, go back to those expected ones. They might be exactly the same. They might not be. All we can say is we don't have enough evidence to say they're different from those. So that is the chi-squared goodness of fit test. So I'm going to start with the blue ones because those are my favorite. Actually, some people say they taste different with the colors, but I don't really understand that. I think they all taste the same. So one last thing, I thought you would appreciate this. So you might wonder, like, how many screens does he have? I've got like a document camera with my M&Ms right here. So I thought I'd show you that. And so, yeah, I've got the, wait a minute. So if, I think I might have a little too many cameras going in my room. Anyway, thought you'd appreciate that.